The Earth's magnetic field is fading, but there's no cause for panic. Our planet's magnetic field, the invisible shield guarding us from harmful solar particles, is showing signs of weakness. Compared to 1845, when scientists started monitoring it, it's about 10% feebler. If this trend continues, the field could even flip, causing compasses to point south instead of north. Hollywood, ever eager for disaster narratives, has already spun this real-world phenomenon into The Core, where a collapsing magnetic field wreaks havoc. But scientists assure us apocalyptic visions are unfounded. Magnetic reversals have happened before, and life didn't stop, says Gary Glatzmeyer, an expert on Earth's magnetic field. He and his colleagues are studying this gradual weakening to understand the Geodynamo, the churning mechanism deep within Earth that creates and maintains the field. The Geodynamo shields us from the sun's charged particles by deflecting them towards the poles. Without it, Earth would be exposed to more cosmic radiation, potentially disrupting power grids, scrambling spacecraft communication, and even widening ozone holes. Some animal species, like birds and turtles, also rely on the magnetic field for navigation. However, scientists emphasize that even without the field, life would persist. There are natural fluctuations, some small, some large, says Peter Olson, a geophysicist. The large ones from geological records are associated with reversals. These reversals happen, on average, every 200,000 years, though the intervals vary greatly. The last one occurred 780,000 years ago. A pole reversal could still have some impacts, though not necessarily as dramatic as Hollywood portrays. Here's a breakdown of the potential effects. Without the magnetic field's full shielding, some additional energy particles from the Sun and cosmos would reach Earth's surface. This could potentially disrupt satellites and electronics. Increased radiation could damage sensitive electronics on satellites and spacecraft, affecting communication and navigation systems. Harm human health. While the atmosphere provides some protection, extended exposure to higher radiation levels could slightly increase the risk of cancer and other health problems. However, the increase wouldn't be significant enough to cause widespread harm. Disruption to animal navigation. Some animals, like birds and turtles, use the magnetic field for navigation. A reversal could temporarily confuse them, but they would likely adapt over time. Geomagnetic storms. The reversal process itself might involve periods of more intense geomagnetic storms, causing auroras to be more frequent and potentially affecting power grids in some regions. While the weakening trend is real, Glatzmeyer assures us it's a slow process on a timescale of thousands of years, so no need to panic. However, future generations might witness a reversal, and by then, scientists hope to have deeper understanding and be better prepared for any effects. The Geodynamo is believed to be powered by the churning of the Earth's molten iron core. As the hot inner core heats the liquid outer core, the liquid expands and rises, generating electric currents and consequently a magnetic field. Additional currents are created by Earth's cooling and rotation. These currents constantly replenish the field, but sometimes a new field can line up in the opposite direction, weakening the overall field. If this process continues, the original field could be overwhelmed, leading to a collapse and potential reversal. However, Glatzmeyer believes it's more likely the original field will regain strength and overcome the instability. So while Earth's magnetic field is indeed showing signs of weakness, it's a gradual process, and there's no immediate cause for alarm. Future generations might witness a reversal, but by then, scientists will hopefully be better equipped to handle any potential consequences.